You think about microbes, comparing them to us, basically they're going to use some carbon source that either we give them or a carbon source that's in the environment. So just like we would eat bread or chocolate or something else and get our carbon that we're going to build our tissue from, the microbe will take some contaminant. So let's say hydrocarbons from gasoline, they're going to take those, break them down, actually use them to build themselves up. And obviously in the process while they're growing, they're going to be breaking that contaminant down. So the contaminant that they're going to break down, the time that they're going to do it is going to vary. They can go from days to weeks, depending on how optimized the process is. You know, are we actually pushing them a little bit to break it down faster? So, you know, a process of taking compost and turning it so you're adding oxygen so the microbes are getting what they need to work quickly, that's going to give them the ability to break down that contaminant faster. So that can be from days to weeks. If we push them, as that example I gave you, you can go from taking years to break contaminant down to being able to do it in weeks to months, possibly even days if your process is very optimized. And the nice thing compared to other technologies that are available out there is the microbes are going to be a lot cheaper. And rather than transferring that contaminant from one place to another, they actually break it down in place. No, typically what's going to happen is if you're going to look at oxidation of that compound, let's say under conditions where they have plenty of oxygen, they take a contaminant like a pesticide or an aromatic ring that you're going to find in gasoline or something like that. Over time, these microbes, since they've lived in that environment, have developed the enzymes that they can actually break down that contaminant. So what they're doing is taking individual carbon from that hazardous chemical, so they break it apart so it's no longer that hazardous substance anymore. And typically what a microbe is going to do is use that carbon either to make more microbes or turn it to CO2, so it'll just blow it off as CO2 just like we do when we breathe. So go out there, and basically what these are giant cores that a drilling rig has gone down and basically take a cylindrical portion of the soil, and then we can bring that back to the surface, seal it, and then we can bring it into our labs and basically use it to begin stimulating, finding out what microbes are there, looking at what genes might potentially be there. So one thing we can do is go into flasks like this where we end up having soil in one of these flasks shaking around. These are obviously have oxygen going in because they're not sealed to the atmosphere. And we can begin monitoring whatever contaminant might be in there, monitoring the microbes that are in there and try to recover them. So things that we might be able to do to recover them then is going to, what we have is basically it's nutrients, but it's not in a liquid form, it's in a solid form, and they're still able to use it. So everything you see, all these squiggles on this plate, are a different type of microbe that we've grown out of a typical type of environment. Probably less than 5% of the bacteria that are in the world can actually infect a human, and they have to grow under certain conditions and at certain temperatures to infect us. So just the safety, these microbes were actually from a hot spring, so I'm not worried about something that lived at 65 degrees Celsius growing in me at 37 degrees Celsius. And typically, from a soil column, these microbes are used to growing around between 10 and 15 degrees Celsius, which is pretty cool. You're close to your Idaho winter, maybe early spring, so they're typically not going to grow in us too. So that's how I look at saying microbes are safe. We're not too worried about having any issues here, with what we're working with, infecting people. So.